In Chapter 19, we're going to build a tool called Blastomatic, which is going to deal with parsing delimited text files. And we've spent a lot of time talking about data formats like FASTA and FASTQ, and you're going to see a lot of that in bioinformatics, but you will also see a lot of delimited text files. And most of the time, quite often, the delimiter is going to be a comma, and therefore the files will probably have an extension of CSV, which is often called CSV files for comma separated value. And sometimes the delimiter is a tab, and sometimes the file extension might be .tab or .txt or .tsv for tab separated values. And those are generally your two most common delimiters are the comma and the tab, although you could have anything. One of the most popular tools in bioinformatics is called BLAST, and it will create a tabular output by default for one of its formats. And so you will probably often find yourself dealing with BLAST output. And unfortunately, the default output does not contain the column header. So I chose this format because it presents a lot of difficulties, and I'm going to talk about a lot of the difficulties that you may encounter when dealing with these kind of delimited text files. So there's quite a bit to talk about in this chapter. I'm going to show you how to deal with delimited text files using both the CSV module and the pandas module. And we're also going to touch on some tools that you can use on the command line like CSV kit and CSV check to look at delimited text files. And so that's what we're going to be talking about here. So real quick about BLAST, it is perhaps one of I think it may be the single most cited tool in bioinformatics. And it's in Chapter 6, we touched just a little bit on trying to figure out sequence similarity using the Hamming distance, which is a very poor way of figuring out how similar two sequences are, because we generally, we start at least for that exercise, we started at the beginning, and we found that even though two sequences might be almost completely identical, if you were to line them up correctly, starting at the beginning, they were very, very different. So BLAST does a local alignment, basic local alignment search tool is what it stands for. And it will also handle insertions, deletions, and mismatches, and all kind of gaps and such. And so it's pretty amazing to use. You can install it locally and build BLAST databases, but I'm going to show you using at NCBI, National Center for Biotechnology, they have a web interface for running BLAST queries, and I'm going to use some sequences, just 100 sequences that I downloaded from the Global Ocean Sampling Expedition that Ventnor collected on a 2-year expedition around the world to collect ocean samples. And this is a metagenomic project because the samples were taken directly from an environment, and we don't really know a priori what is in these, as opposed to, say, getting some of your cells out of your cheek. We know that we're trying to sample human cells. In this case, we don't know what's in these, and so one of the things we might do is run a sequence similarity search against a database of known sequences that were isolated at some point in the past, and then we will try to align these unknown sequences to things that are known to try to figure out what is in these environmental samples. So if you go into, to get started, let's go into the top level directory. We're going to source the VNV bin activate, and I'm going to do that at a couple of windows, as I usually do. And then I'm going to go into the 19 Blastomatic chapter. And from there, I want to point out the gos.fa input file for GOS, the Global Ocean Sampling. And if we use our seq magique on that, we will get a little statistics on it. We see that we have a few samples ranging in length from 216 base pair up to 1212. with an average length of about 1,000, and there are 100 sequences in there. And if we just want to head that file, just to see what it looks like, these are actual sequence files that are downloaded from NCBI. So this is typically what a FASTA file would look like. In addition to a read ID, there's going to be a lot of other metadata here that we could use to get some ideas about these sequences. And so what I've done here, and I have some screenshots here, but I went ahead and did this locally too. I went ahead and ran those 100 GOS sequences against the NRNT database. So I'm doing a DNA to DNA sequence comparison. And this is what some of the hits look like. We see that there were, here we have a few of the hits, and if we go to the alignments, we see what a BLAST alignment looks like, and we can see where the alignment starts in the query and where the alignment starts in the subject, and we can see all of these bars here indicate exact matches between the bases, but then here is a gap here, I mean not a gap, but here's a mismatch here, and overall this works pretty well. There really aren't any gaps. Oh no, here's one gap right here indicated by this dash. And so this is a pretty strong sequence alignment. And so the idea here is we're not going to be looking at that kind of alignment there by our eye. What we want to do is take the data that BLAST generates, which is going to be tab separated, and we want to be able to parse that. And specifically what we want to do in this particular program is we want to join that with some metadata about the samples, where they were collected, including their latitude and longitude. And we want to be able to marry that together to say, well, this sequence in this area of the globe matched this kind of organism. And so we could start to get an idea of maybe the distribution of these organisms that we know. For instance, this one particular, we matched this particular marine bacteria that I don't feel like trying to pronounce. And so that is what we're trying to do. I show here the same thing, that the screenshot from the alignment, so you get an idea of what actual sequence alignment looks like and how far that's different from what we were doing in the Hamming distance. If we look at the input files that we have, what I did was I took the results from that BLAST search and I put them into two different files, and I just kind of arbitrarily split them into 500 and 255, and the idea was just so that I would have more data to work with. But we have a total here of 755 hits that we got, and let's just take a look at what those look like. And this is not a tab delimited, but it is a comma separated file that we have here that we don't know what these columns are. We can guess here that is the read ID from our global ocean sampling, and then this is the organism ID that it hit. But we have really no idea what the rest of these columns are, and so we're going to talk about that. And what I want to say is that if you're running BLAST on some sort of a remote server, probably on your HPC at your university, or maybe you have access to the cloud, you're going to perhaps have very many of these files, and they could be quite large. They could have millions of results in them, and you're not going to be able to open these up with like an Excel program to look at them in a graphical user interface. You're going to have to figure out ways to look at these files on the terminal, probably over a limited bandwidth. And so another thing to point out is that Excel is limited to about 1 million rows and about 16,000 columns. Well, I think the 16,000 may be a hard limit. And so it is not inconceivable that you could have some sort of a crazy output file in bioinformatics that has more than 1 million rows and or more than 16,000 columns. And so you're just simply not going to be able to use Excel to look at tools like this. So I'm going to show you some other tools that you can use, including CSV Kit and CSV Check. So both of these should be already installed. I will say, so CSV Kit is a Python module, and you can install it with a pip. And then we can, for instance, use this CSV look program that is installed with CSV Kit. And we see here that it has determined automatically, it's figured out that this is a CSV file. That wasn't hard to do since it was .csv. And then it split these columns up on the commas, and since there aren't headers, and it just kind of guessed, oh, actually, maybe I told it there are no headers. So it made up some header names, A, B, C, D, and anyway, we don't know what they are, but we can now more easily see that these are integer values and numerical, floating point values and such. And I think it's even, let's see if I make my screen a little larger. No, it's still truncating this K. I was curious if we could get it to print all of that. So it's truncating some values, and so it's not perfect because as you get wider and wider files, you could just run out of. You can't make your screen large enough, wide enough to see all the columns. So I wrote a tool that will transpose these records to be vertically oriented. And I originally wrote it around the time I wrote this book, and I called it CSV check, and it was a Python module. It is a Python module. And then I had a lot of problems getting that to install, and just the tools weren't working well for me with PyPy. And so I went and rewrote it in Rust. And so if you want to install this CSV check with Python, they are almost identical in the way they work and the field names, the option names and such. I tried to make that consistent. But I'm going to be using the Rust version, and you can install that with, if you have Rust install, you can do cargo install CSV check. And they're both spelled the same. And mine is already installed, so I don't need to run that. And it may even be available as like a brew package. I'm not sure about those things. Anyway, the idea, however you go about installing it, the idea is that it will vertically orient the records like this. And so if we run that now, no matter how many columns this has, we're just going to see it. We'll be able to see all the data in all the records. So we weren't able to see what was in this second to last column. It got truncated here. And so now when we look at it like this, we're able to see, oh, the reason why is because was it going to try to add 135 zeros before the 6.18? Anyway, that's obviously kind of a ridiculous way to try to look at that data. So this is probably what's raw let's just look at that, and we see here, yes, indeed, it's just scientific value. And CSV Kit was doing something clever, which is turning that into an actual number, an actual floating point number, but then it's such a ridiculously long number that it can't show it, so it has these ellipses. So at least in this, it's not doing anything fancy, it's just showing us the text here, but we're actually able to see what the value is. We still don't know what the fields are, and that's really annoying. So let's talk about why that is. So if we run BLAST, and I have BLAST in for BLAST nucleotides. If I have that locally, and if I run it with -h, it's a little bit of an interesting program in that the -h shows you this as the help, and the long flag is actually, there's no -- help. It's just -help. That's considered the long flag. And then when you run that, you actually get a much longer version, much more detailed version of all of the help documentation. And if you scroll through here, you can see that one of them is called out format. So when we run BLAST, we can get all these different kinds of formats, including the alignment format. But what we want is this tab delimited format that tells us about a summary of each one of the hits without the alignment itself. And so I show here that if you scroll through this, you will find this section called output format, and what it wants is an argument of some sort of a string. And these are the various values that you can use. You want to just use the number over here, and the default here, the one that most people use will be output format 6, and it's called tabular, meaning table, not meaning that it's using a tab delimited, but because obviously you've seen it's actually CSV file. And then there's this tabular with comment lines. And you may think, oh, the tabular with comment lines, that's the one that's going to have the column headers. But if you go run this, and I don't have an option, an example to show you, you'll see that the column, they're all put in as comments, which are skipped by most programs that will read these kind of files. and it's going to usually recognize a comment character or something like a hash sign at the beginning. And so they end up just being useless. So it's very disappointing. I really hate that this version doesn't have column headers. It makes it so much more difficult to use this, and it's one of the most ubiquitous tools. So you will encounter this most likely, and so I'm going to show you how to deal with this. You could go, I say here, you could go through a bunch of stuff to figure out how to pull that data out of the comment characters and then, kludge this together. But it's really gross. So what are the column names? Well, if you read through all of these are the column names that you can ask for. So you can say you want a tabular, and then you can specify the columns that you want. But if you just say 6, then by default it says here, in the case of options 6, 7, and 10, options 6, 7, and 10 can be additionally configured to produce a custom format, and it has a lot of information here. But by default, it tells you that these are the default fields that are selected: the query accession version, the sequence accession version, the percent identity, which we're going to need to know, the alignment length, the number of mismatches, gap open, penalties, and such, start and stop for both of the query and the subject, the e-value, which is very important, and then a bit score. And there's so much to say about BLAST and these outputs, but all we're going to be really worried about right now, I'm just going to, for lack of anything better to do, we're just going to really focus on this percent identity. And so one of the things that we can do with CSV check is we can actually tell it what the what the column headers are. And this shows a CSV check using the Python version. So if I run this, then I need to, I'm going to fix that. And in the Rust version, I call this -C for the column headers. In the Python version, it's -F for the field name. So when I run CSV check with the same input file, but now I tell it what the field names are, then now it labels things, and oh boy, that's so much easier to deal with. So that is why CSV check is nice, and I'm not sure if you can do that with CSV look. So it's very nice to have that. So I show you here that you can add an alias to your to some sort of like a bash rc file. If you're using bash, it could be called anything from bash profile, bash rc, .profile. On my Mac here, I'm actually using, in my home directory, a zsh is my shell, and so I have here, it may be hard to see, I'm worried that the bottom of this will be cut off. Let me move this up. So we have here, I have this alias blast check bls chk, which is alias to csv check -c with the column names, and then there's no other argument here. So if I run blast check, for instance, like this, blast check on test inputs hits.1, then we see here I don't have to remember all those column names or search through my history. It's just set up as an alias that I can use. So that might be something that you find useful to install on your own in your own RC file, whether you're using bash or zsh. And if you're using blast hits a lot, that could be something that makes it a lot more convenient for you. So I show here what blast check looks like. Here I have it with a T, however you want to spell it, whatever you want your alias to be. And so the goal of the program is to link the blast hits to the depth and location of the sequences themselves. And that is in a file called meta.csv for the metadata. So let's look at here, what I'm going to show you here is one of the options to CSV check is -G for grep. So what it's doing is it's looking for this string in this file, and it's right now it's looking at it like looking for it anywhere on the line, and so it finds record 92 actually matches this the sequence ID. And so what I've done is I've pulled out from the meta this particular read, and I see that it was collected on this date at this depth with this salinity at this temperature and this latitude longitude. And one of the interesting things to note is that the latitude longitude is itself comma separated. And let's just look at that file. Let's see what it looks like. You see that the file itself is comma separated, but that this field here is additionally surrounded by quotes, and that's necessary because otherwise this would look like an additional record separator. And this is part of the reason why I chose this data, is because it's something that you may encounter and you really need to understand about escaping these kind of sequences. So one of the things that so what I want to do is I want to be able to join hits with the meta, and I should be able to do that because in both of these there's if we grep for this in test, and let's just go into test inputs, and I'm going to grep for that in hits.1, and we see that there are 4 records there. And if I grep for that in the meta, I see there's 1 record here. The idea is that for each one of these 4, I want to be able to get at this data here. I want to be able to know its latitude, longitude, where in the globe we can find this, this hit, this organism. So that's kind of interesting. And there is actually a program called join. And part of what I've wanted to do in this book is, in addition to tell you about Python and all the cool things you can do with it, I also really want you to know about other tools that would obviate the need to even write Python code. So one of the things you could do is you can join these files, and I'm using -t here for I think this is the delimiter, and I'm feeding it 2 files. This hits.csv, and it needs to be sorted, and the meta.csv. And if I do this, what we see here, let's just run this, and then I'm going to pipe the results into CSV check. And what I see here is that the cam read has been joined to its sample file, and I get here that this read is with this hit to this organism was found at this depth, on this date, at this location. That's pretty cool. So join is really a very cool program that you could use to join two files. And the idea here is that how do we do this in Python? So that's what I'm going to show you. In addition, we're not just going to be just reading CSV files. We're going to be reading 2 CSV files and figuring out how to join them, which is essentially what a lot of databases will do for you. And so if you understand this, so getting started one last time here, we're going to go into the 19 Blastomatic, and we can copy just any one of these solutions to Blastomatic. And I am going to go ahead and encourage you to try to do this on your own. It's another one of those ones that it's really so complicated that it's really kind of unlikely that you'll be able to come up with this. But you know, I'm gonna try to get you part of the way there and see what you can do. What we see here, there's quite a few quite a few arguments here, but the 2 that we have to have, you see here that this is a little bit different. These are options, but they're not actually optional. So you see here, all these other options are shown with square brackets around them, so they are truly options. But here, what I have are 2 required arguments to the file. The -a is the annotations file, that meta.csv, and -b is the blast hits. I could have called it hits, but then I might have wanted to use -h as the short flag, and I can't do that because -h is solely reserved for argparse, so don't want to use that. So it actually looks kind of funny because it's -a and -b, but it's annotations and blast hits. And those 2 are required, and I could have made them positional arguments, but then I would have had to remember the order, which one comes first, annotations or blast hits. So I decided to just make them named arguments, and they're required. And so I'm going to show you how to do that. Otherwise, you see all these others have reasonable defaults, and we can output is going to be into out.csv. The output field delimiter it's actually a tab key, and so this is kind of funny. It's showing you a literal tab key, which just is an unprintable character. So that's a little weird. but there's kind of no getting around it. And then the minimum percent identity, which defaults to 0, but then we can use a percent ID to limit the number of records that we take. For instance, we don't, we're going to use 90 here, which is a really low threshold, but that's the way I wrote a lot of these examples. So we have some reasonable defaults, and let's look at how the program works by default. And so you can get an idea of how you would go about writing this. And so I ran it saying that these are the blast hits, the hits 1, and then the annotation is that meta.csv. And what we see is that it wrote to an output file called out.csv. And so I can use the CSV look to see what that output file looks like. And in an earlier version of the book, I did not include the subject sequence ID. I only had the query sequence ID, and so really kind of a useless output. So I decided for this exercise to update the book. So if you have an older version of the book, see if you can go get a new version of the PDF. But I will be demonstrating this program. So we see here that this read hit this sequence ID in BLAST with this percent identity. This one's 92, which is actually pretty low. 85, we're going to want to get rid of that one. And we have here, in addition, we know what depth it was collected at and the latitude longitude. And so if we look at the raw file, we see here that it's the same deal, that everything has been all these other fields are fine. They don't need quotes around them because they don't have embedded commas. But this last one does need quotes around it because it's because of this comma right there. And we see that it was properly written out so that we can use tools to look at this. We could also use CSV check to do this. So here I did max rows is 2. In CSV check, it's called limit, and the short flag for that is -L. So I could do like this. -L, limit 2. And so it, again, vertically orients the output so that I can read it. And the CSV look is fine in this instance here because the table is not too wide. And so here I'm showing that I can also run this with a percent ID of 90. And we see here now it's only exported 190 records to CSV, and I can double check that by looking at out.csv. It actually reports in the 191, and that's because of the header line is there at the top. So this is a properly formatted file because it has the headers that tells me what the fields are. And so when it says it exported 190, that's the number of data rows, and so it doesn't include the header line. So, and I can also look at the output of that using CSV look, and we can verify we're not seeing any percent identity that's lower than 90. Now, if I wanted, I have a little sidebar here to just talk about some other tools that you would use quite often on the command line to work with delimited text. One is called cut, and let's say I want to go through and actually verify that every single value that's in the third column is actually above 90. So how would I do that? I don't, I could look into CSV look. Is there a way to tell it only print the third column? I'm not sure. I could go read the documentation. But I definitely know that there's a program called cut. And by default, the field delimiter is a tab character. So here I'm doing -D to say that the comma is going to be the field delimiter. And I want the field that I want it to print is the third one. So this is one-based counting here in cut land. And this is the input file that it's going to give me. And so if I want to see just the head of that file, I see that yes, it is giving me the third column, which is PID, and then it's giving me the first row, and then the second row is 92. And so I could get rid of that and just say, look at all of them. Yeah, I mean, just visually, I can scan through this, and it does look like they are all over 90. But what if this was a million rows, and I don't have a million rows of scroll back, and I don't want to look at this by hand? That's kind of gross. So another tool I could use is called awk, and that the name comes from the 3 authors. I can never remember A and W, but K is for Kernighan, who helped write C and Unix. And so the same here, I'm using -F to say it needs to split on commas. By default, awk splits on any amount of white space. And it's a little different here in that it needs a bit of code to tell it what to do, and that bit of code needs to be in curly braces, like a block of code. And it's using $1, $2, $3 for the first column, the second column, the third column. So this is $1, this is $2, $3, and so I'm telling it print $3. And if we look at that, we just look at the first two lines of output. You see, it's the exact same output from cut. And so obviously, if I get rid of all that, then I'm getting the exact same thing as from cut. And so there's an additional bit that can come before the block, which is some sort of a condition that has to be true in order for this block to execute, which I'm going to use here in a minute. A very important note here is that this block here, this argument to awk must be in single quotes, because if I put it in double quotes, then bash or ZSH is going to try to interpolate this string, and then it's going to look inside its own environment for a variable called $3 and interpolate that, and I don't want that. So I've mentioned before, in Python, single and double quotes, they have no difference. They both create strings. But in the shell, single quotes do not do variable interpolation, and double quotes do. So it's very important that that be in single quotes. And it's something that you get used to with awk, but if all you need to do is simply print a particular field, then maybe you just go use cut. The thing I will say about both of these tools is that neither of them will respect that last column where, let's go look at the out.csv again. They will skip over the fact that this is inside of quotes, and we'll go ahead and separate on that. And so it's not a problem because this occurs as the last field in the record. But if this were the first field in the record, then it could possibly throw off everything else behind it. And so in my book Command Line Rust, I actually show how to write a Rust version of cut called cutter, and it will use a proper text parser, and it will properly escape that, and so it would not be a problem. So something to be very aware of with both cut and awk is that they will not handle these escaped delimiters. So knowing that, we could go ahead and say, okay, if I cut this and I look at the third field, then, what I want, so this will give me all of those columns, and what I want is I can actually pipe it into awk, and I can do this little test here. And now $1, so this is now going to be $1 that's going to be piped into awk. Let's look at that. Awk. This is going to be $1. And if I say it's greater than or equal to 90, it's not going to work. And let's look at that. Let's look at the head, because it still spits out the p-ident. And in just kind of the weird way that it goes about trying to compare a string and a number, this just doesn't work. So what we have to do is we have to basically force awk to turn this into a number by adding 0 to it. And now you see p-ident has been left out. So I'm taking this to get the third column, and then I'm using this as the condition for awk. If this is true, then by default I don't have to tell it to print anything. It's just going to print the line, which is $0 in this case. And we see here, if we count those, now we are instead of putting them into head, what I'm doing is I'm now showing you that there are 190 records. And if we go back and look at out.csv, there's 191 lines. So it is true, all of these are above 90, greater than or equal to 90. So that is a way on the command line of dealing with delimited text files. You know a little bit now about cut and awk, so that's useful. With that done, I will say that it's time to start from scratch. And one of the things is you can specify the delimiter to specify a different delimiter and the output file, and we're also going to have a little something to guess the delimiter of the output file will be with a little function that we're going to write. So to get started, let's start from here. New.py, and one of the first things I'm going to do is there's quite a bit to type, so I'm just going to go grab all of the top part from one of my solutions, because those are all going to be shared. Let me go to solution 1, that'll be fine. I'm going to grab all of this, not going to look at the answers. And I'm going to go down here, start off by just printing args, that'll be fine. And then we'll take a moment to talk about how all this works. Let me run Blastomatic -h, make sure it works. It looks exactly the same as the book. So let's talk about how I define these arguments. First off, we're going to have our basic args. It's going to have our hits is going to be a text IO, an input file. Annotations is also going to be an input file. Out file is going to be an output file that we're going to and we're going to open in write mode. We're going to have a delimiter that is going to be a string, and if the user doesn't give us a value, then we're going to go guess the string. That should be used as the delimiter. And there's going to be a % identity, and it's going to default to 0. And so let me show you how that looks. There's really nothing new here. We're still using the arg parse file type to validate the input file. And this is the help is saying that this needs to be blast output format 6. So we're not going to have the user tell us what the fields are. We're not going to have to guess about that. We're saying this needs to be output format 6. And so we know what the fields are. We're going to take some annotations. That's also going to be a readable text file. And the thing to note here is that normally these are optional arguments, but I can actually make them to be required by saying required is equal to true. And because of that, I like to put them first, kind of like they're positional arguments. But again, I didn't want to have to remember which order to give them. So I decided that they should be named, and both of these are required is equal to true. All the other ones have defaults, and they are not required. And so it's going to default to out.csv. It's going to default to either right now, we're actually going to add something here to make this to be guess, or we're going to guess the field delimiter. And we're going to have a %ID. It's going to default to 0. And this should be a floating point number. And so anything that I give on the command line will be it will be coerced into a float. And I'm making sure that the default here is 0 point, which is a shorthand way of writing 0.0. With that, I'm going to return the arguments. And here's this little trick, that the delimiter is going to be equal to whatever they've given as the args delimiter, or I'm going to guess the delimiter from the output file's name. So if you tell me .csv, I'm going to guess that the output delimiter should be a comma. But if you tell me text or tab or tsv, I'm going to guess that the delimiter should be a tab. And so with that, I would challenge you to go ahead and think about how you would make that work. So we're going to need a guess delimiter, and it's going to look like something like, let me get my little separator here. We're going to have, let's just write it here. It's going to be guess delimiter, and it's going to take some sort of a file name, which is going to be a string, and it's going to return a string. And for the moment, let's just return a comma. That'll be fine. And so with that, with a minimal working version of a guess delimiter, we're going to run PyTest on our Blastomatic program, and we'll see that it passes this first one because it is a comma, but it's failing here because it wanted a tab and it got a comma. So I would challenge you, first off, given a file like foobar CSV, it should return a comma. but in the case of text, TSV, or tab, it should return a tab. And otherwise, it just basically should always return a tab. In the only case it should be a CSV file is that that's when we return a comma. So pretty straightforward. You should be able to write that. I would suggest you go do that first, and then after we print here, we could just make sure that our program is working. Let's go ahead, because guess delimiter is going to return something. It may not be the right thing. Our code should work at this point. Let's try running our program with, so it's called Blastomatic. We're going to use for the annotation file, it's going to be test inputs meta, and for the blast hits, it's going to be test inputs. We'll just use hits1.csv, and we should see, yes, the hits is the hits file, and the meta is the meta file. And so we are doing okay so far. You should actually be able to pass a few tests. Let's see what we have here. A few problems. Yep, it's failing on test guess delimiter. So it's, you can play with you can also just run PyTest directly on test, the Blastomatic test, and it will pass some of them. It will fail a lot of them. So a good place to start. With that, let's now talk about how we can parse delimited text files using the CSV module. And it does a lot for you. And so the first thing I want to do is to prove to you how much it does for you. And to do that, I'm going to start off by going into my REPL, and I'm going to create a file handle to read the meta file. It's going to look like this. And I'm going to call FH read line, which will read the first line of text. So with a line of text being defined by the first new line, and then it's going to include that new line. So I'm going to call rstrip on that. That is then going to be split on the commas, and what we're going to see are the headers. The first line in the file will be the header line. And so if we look at headers, we see it's seek ID, sample, date, all that. It's exactly what we expect to see from the meta.csv. Now we have a problem, and the problem I've already pointed out, and the reason why I chose this data is that the next line is going to have this embedded comma here, and I'm going to prove to you that this doesn't work very well. This is what line looks like. Let me make my screen a little bit longer, and you see here that it still has the new line attached, and we have this comma here that is going to be a problem when we take this and we split the line into something called data, and we look at data, and we see here that we actually have that last column was split into two values. And so what we want is that to be one value. We also need to get rid of this new line. So there's a real problem here in that the length of the headers is not the same as the length of the data. So we would not be able to just go and split this line like this. So we need a better way of doing that. And there is in this module called Parsing, there's, I had to go really looking for this, but there is a way in Python to get it to handle that well for you. It's really a bear to use. But let's use this very complicated bit of code that I can't even remember how I found it. But now we see that it has properly handled a comma-separated list, parsing this line and returning it as a list. I would never have been able to come up with this on my own. But you see here it has now preserved that last field intact because the quotes are around it. And so, if you just are thinking to yourself, oh, I'll just parse this data myself, I'll just split it on the delimiter, you need to be aware that you could sometimes encounter this kind of embedded delimiter. And so it's probably a bad idea for you to not use something that will handle that. And so I need to get rid of the quotes. So the other problem here is that I got these quotes around it. Well, now I've got to get rid of the quotes. So I'm going to import the regular expression module, and I'm going to show you a quick little way that you could use RE sub. And the way that I'm writing this is that at the beginning of the string, there's a quote, or at the end of the string, there's a quote. And I want you to substitute that pattern with the empty string in this S, this thing called S, which I'm using for string, that goes into this lambda for this map. And if this seems complicated, it is. And I'm trying to show you that it's complicated because there's an easier way to do all this. So that's what data looks like now. It's now been pretty cleaned up. We've had to go do some really, really manual stuff to get this data in a usable format. And we still have these two different data structures. We have this headers and we have this data, and it would be nice for them to be together so that we know what these pieces are, so that I know that 25.4 is temp. So we have seen something like this, and for the I'm going to pull in my pprint module so that we can talk about zipping. We have before I've showed you zip, and so if we zip, we get the zip object. And so if I need to pprint and I have to list that, and we get here that zip will create this a list of tuples where it takes the first value from headers and the first value from data and puts them into a tuple. And then it does the same for the second from each one and the third for each one. And as you remember, zip stops at the shortest input. And so we also learned about zip longest, and maybe you've gone off and written your own. And that's really cool. I just need to go one step further. I want it to be a dictionary. So if I replace list with the magical word dict, now I have a dictionary. And so now I could put that, instead of p-printing it, I'm just going to put it into something called val. And if I say val at temp, whoops, I can get 25.4. So that is nice. Wouldn't it be nice to put all of that into some sort of a bit that we could use over and over again to read the header line from the file and marry it with the data lines of the file and create a dictionary? And I'm here to tell you that it exists. It's in the CSV module. CSV for comma separated value, but really it deals with any delimited text file. So if I import CSV, I can create something called a dict reader, which will create dictionaries of each of the records, marrying the header line with the data lines. Or in the event where there is no header line, you can tell it what the fields are and it will create a dictionary for you. It's very nice. I'm just going to say rec is equal to next from the reader. It is an iterator, just as we've seen before. And if I say pprint on rec, I have all of that done for me. So all of that I showed you was just to tell you that you don't have to do any of that. You have this really nice thing called a dict reader, and it will do all of that for you. And I didn't have to tell it that the headers were in the first line of that file, because that's the default for most of this data type. And it's really blast output format 6 is really the outlier in that. So how can I use this in my program? So after I call get args, I can create this thing called annotes reader. So I'm going to get rid of those lines. And I'm going to create this reader for the args annotations, and I'm going to tell it that the delimiter is a comma. And so this is hard-coded. I could also use my guess delimiter on the name of the args annotation file. And if it's a CSV, then it will use a comma. And if it's any of these others, then it will use a tab. So that's another way that you could improve this program if you wanted. I happen to know I'm dealing with comma-separated files, so I'm just going to stick with that. I'm going to create this annotations. It's going to be a dictionary. So here, instead of a list comprehension, I'm using a dictionary comprehension. So I'm creating this dictionary that is going to be keyed off the sequence ID, and it's going to have as its value the row from CSV dict reader. And we can look at that. I can p-print that for you, and we can look at what that looks like. So let's just run this now. And it's always useful to look at the output from your program. Tell you what, I'm going to leave my that REPL open. I'm going to open up a new window here, source v&v bin activate, so that I can go into the 19 directory and I can run Blastomatic. Using the annotations is going to be test inputs meta, and the blast hits is going to be test inputs hits.1. And if we look at this, CSV is not defined. Let's go up here. And I think I also need to import OS, if I remember correctly. Let's just give this a try. We're trying to learn, let's see, from pprint import pprint and I'm only going to use this temporarily, so I'm putting it there to remind myself to get rid of it later. And this is what it looks like. So it has read the annotations file, and let's just do a CSV check on test inputs meta. And we'll just look at the first one. We see here that there's this JCVI ID, and then it has all this other information. And what we see here is there's the JCVI read ID. It is the sequence ID from the record, but that is now the key in this dictionary. And it is assumed that this is going to be unique through the file, because otherwise we would end up with whatever is the last version that we saw. And that's okay. So again, what we did here, if this is a dictionary comprehension instead of we've seen before, list comprehensions have the square brackets like this, and so if we did this, actually, let me just show you real quick. We could do a list comprehension, and it will create a list of tuples that have the sequence row ID, the sequence ID from the row, and then the row itself. And so that's what we've got. And if we were to then turn that into a dict, we would get the exact same thing. That is a dictionary. So we could get rid of all that and just basically, this is how we create a dictionary with the same result, but a much cleaner syntax. So this is a dictionary comprehension, and that is a way to get a lookup table basically for all the annotations that we have. Now, if we were dealing with millions or billions of annotations and reads, this would be a terrible way to go about it, but I'm just trying to lead you up to the idea of what does it mean to join to data files like this. And so we're going to have some sort of a lookup mechanism, and the key between them is going to be this sequence ID. So, you know, if we take this, like this read ID, and we grep for that in test inputs hits 1, I hope we find it. So we're not finding that one. Can we find this one? Well, let's just take head of test inputs. Let's just take the head of that. And this is a cam read. So if we were to grep for this in test inputs meta, and then we were to grep for that in the hits.1, so we're going to find it. So so not every read in meta is going to be found in the hits. That's just the way it works. And so we want to be able to key off of, this is the common key between these two files. So, you know, how do we marry these two files using that shared key? And I already showed that with join, and I'm now going to show you how to do that with Python. So we have this idea here. I've showed you how to create a dictionary of the annotations, and then I'm going to show you a very longhand way of creating this output file, and then I'm going to show you a better way to do it. So to create the output file, these are the fields that we want there to be in it. We want to have the query sequence ID, the GOS, the GOS sample ID, and then we want to have the subject ID that was found in the NRNT database. So this will be the organism ID, the percent identity, which would, you know, for this match, and then so the percent identity is coming from the hits file, and then the depth and the latitude and longitude are coming from the meta file. So if I take these headers, and instead of printing the annotations, I'm going to have my headers, and then I need to print my headers to my output file. So because I used argparse file type, and I open this as a text file, I can write to args with whatever delimiter I guessed from the guess output, from the guess delimiter. So this guess delimiter is going to return some sort of a delimiter. That's going to be a character. I'm going to call join on that character, and I'm going to join the headers, and I'm going to write those to the output file. So I'm getting you started here with thinking about how you can get a map of the annotations, a dictionary, how you can get your output file to have the headers in it, and then you're going to have to figure out how to go through the hits file and marry the hit to the annotation and then write it to the output file. So another way to write this line is to use a print. So you can say print args delimiter join headers. to a file of args.out file. And this is, out file here is an open file handle that you can write to. So with that, this is what we have so far. I'm going to show you how you can use CSV dict reader to read the blast hits. And it's you're going to have to specify the field names because because the field names aren't at the first line in the file, and so that's going to look like this. Let me fix my formatting real quick. And my formatter, I'm using black, and for the book I used YPF. So they're slightly different, but breaks them up here. But I have the field names, and those are the same field names that I was showing you before from output format 6. And so I'm using a dict reader on the hits file handle. I'm hard coding it here I know this is a CSV file, but I could again use my guess delimiter to guess the delimiter from the args hits.name. But now I have to specify what the field names are so that I can then get back a usable dictionary. Otherwise, it would take the first line of record, and it would use whatever it finds as the data, which would be totally useless. Now I have something I can iterate over. CSV dict reader is a lot like the seek.io parser in that I can now just iterate over this sequence. It's like an iterable, a sequence, an iterator kind of a thing. So I'm going to iterate for hit in hits, and I'm going to go ahead and add in this little test here. This is how I'm going to skip over where percent identity is less than whatever it was given as the percent ID that in my arguments. And so this is going to default to 0. So this will by default let everything through. And so hit, remember, is going to be a dictionary. I'm using dict reader to get it. And so I can use hit.get on the field called percent ID, which matches right here. And if there's nothing there, I want to have it give me -1. So that basically it will just allow all the records to pass through. But this is the way one way that I could use to skip over the records that are too low of a percent ID. And otherwise, I'm going to print, I just need to print something here. So I'm going to print the query sequence ID, just so that I can now run my program. Do I have, yeah. So I can run this, and I see a bunch of output. And let's see, how many records did I get? 500, so I got all of them. And so what I show here is that let's now run it with a percent ID of 90 and make sure that I only get 190. So that is without specifying any percent ID, but when I specify percent ID of 90, I only get 190 records, which is the expected. So we've looked at an entirely manual way of parsing delimited text files, and then I showed you CSV dict reader. And I'd like to now show you that you can also use something called the pandas module. And it is very much based upon ideas from R. And so if you are familiar with R, there is a read CSV function that you have probably used, and it will read an entire file into something called a data frame. And so this is exactly the way pandas, it tries to emulate that. Inside of pandas, which is often imported with the abbreviation PD, like we saw NumPy is often imported as NP. Pandas is often imported as PD, and it has a function called read CSV, which reads a file into something called a data frame. It has an option for a field separator, and the default is a comma. So the easiest way, I'm going to show you real quick how to import import pandas and read the entire file in one fell swoop into a data frame. I have a note here. If you are trying to parse this with anything other than a single character, you'll have to specify the engine is equal to Python. So it's a little bit of annoying. Anyway, so continuing on in our REPL that I have open up here, let me find that. I'm going to import pandas as PD, and now I can I can read the entire meta file with just one line of code. And that has some advantages and some disadvantages. So let's look at what meta looks like. One of the things is that I can get a real quick idea of the entire file. It has to fit into memory. So if there are millions and millions of rows, this may not work. But if you actually need to do data analysis over the entire file, like you need to find the average of the temperature, or things like that, then this makes a lot of sense to use pandas. And so maybe you'd like to read it all into memory. And so I have a whole thing there here about, again, thinking about if the file can fit into memory. And for a lot of, especially metadata files, probably they will. If you have to process millions of rows, then I would recommend that you use the CSV dict reader, because then you're only ever, at least with CSV dict reader, you're only ever reading in one row at a time. You still could be storing those into some sort of a data structure, not out of memory. But this CSV dict reader is a very low memory way of reading one record at a time, whereas read CSV always reads the entire file into memory. It may not be a problem for you. Something that's quite interesting about this, if I make my window a lot smaller and I say meta, you see here that it actually is very sensitive to the size of the terminal. That's pretty nice. And so it has these ellipses here to show where data has been deleted. It's also showing here that it's showing the first 4 rows first 5 rows of the file, and then this showing here that there's some data that's been deleted in the middle, and then it's showing me the end of the file. And so that's also really useful. Sometimes the data is changing from the top to the bottom of the file, and it gives you just a real quick overview of the size of the data. And finally, it also tells me how many rows and how many columns it has, which is also something that you can find in something called the shape of the file, which is it is an attribute of the meta here object 107, and that is the rows. So if I just ask for the 0th version of this tuple, that is how many rows it has, and the first one is how many columns it has. I can also get at the column names by asking for meta columns, and it tells me what those are. And by default, again, it just read them out of the first row of the file, and it defaulted to separating on commas. And you notice here that latitude longitude was correctly handled. This was escaped, and so this is viewed as one field, which is called lat long. So great. There's more. You can get at just one of the columns by referencing it like it's a dictionary. So I'm calling meta salinity, and again, that's from the meta columns. I can use any of these column names, and I can select out just that column. And you see that there's some data that's missing, but for where it's present, it seems to be of a float. So it has parsed out the character data that's in the file. So remembering that the input file is just a bunch of characters, a bunch of those. It's up to the program to decide whether or not that is actually some sort of a number, or if it leaves it as just character data, which is what we saw with CSV check and the difference between CSV look and CSV check, using that one value that had an extremely small floating point value in scientific notation. One of it left it as just text, and the other decided to turn that into a floating point value. So pandas is designed to do the latter. It's designed to turn those things into numbers so that you can then do numerical analysis on them. And so I can additionally do some really kind of to my mind, kind of weird stuff that is just taken straight out of R, which is that I can select for the values for the rows from the salinity column that are greater than 50. And what I'm actually getting back is this list of trues and falses. And so what it's telling me is these are the rows. For each one of these rows, it's either true or false that salinity is greater than 50. And so what you actually then have to do, that becomes this mask that you then use on meta to select out the rows for which this is true. And so it's a very, very R way of selecting the data. And to my mind, I would have to look this up every time, and it doesn't necessarily fit with the way that I think about data, but if this, especially if you're coming from R, maybe this excites you and you know that this is another way that you could deal with delimited text files. And we see here that it found 3 rows and 7 columns, so a little bit different output from when I wrote the book. So this is another thing I can use. So this whole thing is itself a new data frame. And so if I wanted to select out then just the salinity column, I can now get at just the values, 63.4 of this new data frame that was created. I've now gotten it down just to one of the columns. So I want to read in the BLAST file, and for this, again, I'm going to have to specify the columns because they're not there. Very annoying. Gene Myers, if you're listening to me, I'd love to see you change that. So I can read in the hits by using read CSV on this same hits file that we've been using before, and now I'm going to pass additionally the names of those columns are this columns that I'm giving in. And so with that I can look at hits, and now I have this actually quite beautiful data frame. And again, you know, blast hits could be in the millions, and so this might not be something that you'd actually want to do. I'm doing this specifically because I'm going to show you how to use pandas to join. And so, but under normal circumstances, you would probably just want to use CSV dict reader to go through this and do your selections. But I'm going to show you how to do it with pandas. Why not? And so I can do, for instance, here's how I could filter for the hits that I want. Are the ones that are, for instance, where the percent identity is greater than or equal to 90. And I didn't have to do any coercion of phits 90 to a numerical version, to numerical data, because pandas already did that for me. And if I look at now wanted, we see here it is now 190 rows instead of the original one. Hits is 500. And that we know 190 is the number we're looking for. And so that is a way here of selecting the rows that I'm interested in. I still need to join them, but we'll get to that. Another way that I want to point out that when you want to iterate over the rows, you can't just use a for loop. You have to call one method here is to do iter rows, and that's actually going to return a tuple of essentially the position, the record ID. It's basically like using enumerate, and then the record that you want. And so let me just show you what that looks like in the REPL. I can do for this iteration, I can print the hit, and then I can just break, and I'll just show you the first one. And so this is what it looks like when you print a representation of a pandas object. It will print it like this, which is quite nice if you are just wanting to look at things. And as you see here, the columns have been named because we gave the names. So if I want to point out here that this thing that you get back, this hit, is itself a dictionary, and so you can use this square bracket syntax to ask for these fields, but you can also use, for instance, hit the .get method of a dictionary. And I'm showing here, like in the case if you were dealing with a file, a bunch of files, and sometimes a particular column was present and sometimes it wasn't, then using this is going to blow up. It's going to create an exception when you encounter a file that doesn't have some sort of a column that you were expecting. So you might be better off using the get method of the dictionary. And so here I'm just showing here that it's printing the query sequence ID, the percent ID, but for nope, which doesn't exist, it's just printing none. So I can, to marry the two, so given in the meta we have some sort of a sequence ID, I can find the sequences that match some sort of an ID. So let's say I'm going through my hits, and let's say I think I'm using this first one, 2157, and I'm going to look for in the meta where the sequence ID is equal to the 2157 that I'm looking for. And so what does that look like? And again, I'm not in love with this syntax, but so I get seeks, and what is that? Well, it is itself it's a data frame. It has a shape of 1, has 1 row and 7 columns. And so it might be the case that I try to find something that doesn't exist. And so I would get back an empty data frame like this, where I'm looking for this value x. I know it doesn't exist, and so I can look at the shape and it's 0. I can also say seeks.empty, which is not a function. It's like a slot there, and it tells me yes, it's true that this is empty. But for the other one where I did find something, I could say I want to know what the first record is in it, and I can use this thing called iloc, which I really dislike. But this is a way of getting at the first object in it. So that would be one way. If you're reading through the hits and you want to go find the meta, you can use this kind of syntax to join them. Don't love it, but it is something you can do. Another way of figuring out is if you weren't able to find anything, you can look at empty, or you could look at the first character, the first slot in shape, and that will tell you the number of rows that it found. One of the really cool things about the data frames is that there is a toCSV method that will do all of the writing of the output file for you. So for instance, I show here, I can actually create a data frame, like I've showed you before, where salinity is greater than 50, and I can then call on that data frame, the toCSV function, and write it to a file. And I'm telling it here not to index the file. We can talk about that in just a minute. But this is what that looks like. And now I can import OS. I can say OS lister, and there will be a salty.csv here that has been written. I can use open.salty.csv, and I can read it. And so that's the data that was just written. I can read split lines and see a little bit better. Let's print that. There. So it wrote the 3 lines of this data frame to this new CSV file for me. And all I had to do was call toCSV. So that is another reason why you might choose to use pandas. It makes it really very easy to read and write delimited text files. I can also go into the command line, and I can use my CSV check program. Let's see if I have here we go, CSV check on salty. And I see it has 1 record. If I do a limit of 0, it'll actually print all of there will be no limit, and it will print all of them. By default, the limit is 1. And so I'm not going to go too much more into pandas. It's really more than I would have time to talk about, but I recommend these 2 books if you are interested to learn more about pandas. So let's go through my solutions. I have 4 to show you, and the first place we'll start is how I wrote the guess delimiter. I'm using split.ext to get off just the extension part of the file name that's been given to me, and then I'm going to return comma if that extension is .csv. Otherwise, I'm just going to assume it's a tab delimited file, and that's generally pretty safe. It's just a heuristic. You could, really get interested, like if it wasn't one of those 3 TSV files I mentioned, tab.txt and tsv, maybe you want to open the file and sniff it and see if you can figure out what the first, what the delimiter looks like it might be. But then, that works well enough. And if I test my PyTest on my Blastomatic, make sure that my one, let's do -b, my one guess delimiter, it passes now. Great. So for my entirely manual way of joining using tables and joining the tables using dictionaries, we got as far as we have this dict reader, which I'm showing here, and I showed you how to write the output. And then we're in here in this this for loop. So let's break this down. I'm going to want to print at the end how many records that I took. So I'm going to create this variable for the number that are written. We already figured out how to skip over the ones with a low unwelcome percent identity. So now I'm going to say I'm going to use the walrus operator again to say if it's possible for me to get a query sequence ID out of this record. And I'm using the walrus to This would just handle badly formatted input data or maybe just missing data or something like that. So if I can get a query sequence ID, if I can then take that sequence ID and go over to the annotations and get a record for that sequence, so it's a second if, then let's just say I'm going to increment num written for now, and then let's just jump to the bottom, and I'll print. I'll close the file, even though I don't really need to, and then I'm going to print this. And let's just make sure that we're getting something reasonable out of this program. So I'm going to go back here. I'm going to go back and run this without a percent. It says it exports 500 to out.csv, and let's put a percent of 90, and it says it exported 190 to output CSV. Great. And now, if you look at out.csv, there's a, oh, actually there is something in it. Oh, because it has, if we look at it, it has the headers. So that's the only thing. So we wrote the headers, but then we didn't write any data. So there's really nothing useful in there. So let's talk about how we're going to write to that file. So I'm going to call the args outfile write function again. So after I've indicated that, and I'm going to first off, I'm going to join on the args.output delimiter. I'm going to show a couple things here. I want to join these values from, let's just talk about this. And then I need to add a new line because write does not add a new line. Let's see if this will, did I get, yes, looks like I got the syntax right. So what I want to print is, oh, actually it looks like I left off a line here. I need to print the percent identity. I need to print the sequence ID and then the subject sequence ID. There's a mistake right there. I'll be sure to add that to the book. And so I want to print, because we're printing query sequence ID, so that's going to be the qseek ID that I get into qseek ID, into seek ID. And then I want to print as the second column the sequence, the subject sequence ID, the percent identity, and then from the meta, if I'm able to get this sequence out of the meta, then I want to print the depth and the longitude. And so let's look at what that looks like. I'll run it without that, and then let's head out.csv. And what we see here is that there's a problem because that didn't get quotes around it. And so if we were to split this line on the comma, it would definitely split that into two fields, and then that would cause all kind of problems for downstream. So we need some way of putting that latitude, longitude back in quotes. And so, one thing that we could do is, and it gets a little tricky here to use an F string. So I'm going to use this little older format string, and I'm going to call dot format. And if we run it like this, so this is the thing that's going to, seek latitude, longitude is going to go in here, and it's double quotes inside of single quotes. So it's kind of it's a little bit of a bear to write. But if we look at that now, this has now been correctly escaped. So there's quotes around this field. And if we wanted to simply do that for all of the values, then we could use a map with a lambda function where given some, and I have it written out here, some value s for a string, we're going to put into an F string s and put quotes around it. And then with that, now we need another parenthesis here. But with that, then what we see is that now we have quotes around everything. And with some of that stuff that I was showing you earlier with doing awk and cut, if you were now to try to, for instance, cut on the delimiter comma -f3 on out.csv, now you've got these quotes around it, and that's kind of ugly. They're really unnecessary too. So then you'd have to do something like put it through sed, where you're going to substitute this. Let's see, did I get that right? Yes. So doing a substitution operator globally substituting the double quote for nothing at all. So this is not great, but you do have to deal with fixing that. And I'm going to show you, it gets easier. This is just an entirely manual way of having to do this. But with that, we actually should be able to, let's run PyTest, and I'll run XV, and I'm going to use some test, Blastomatic test, and that passes all of the tests. And if I call make test, that does a little bit of extra. Actually, it's not happy because I remember this, because I'm still using pprint here, and so I needed to get rid of that. It's a good way to, let's see, now it's not happy with some sort of formatting because it's using flake 8. So I just ran it through my formatter, and that seemed to make it happy. And so now it's passing all the tests. So this works, and if you're happy with this, great, but I'm going to show you how to make it even easier than that. And to do that, I'm going to use dict writer. So we've used dict reader to read the input file so far, but we had to do all of this very manual stuff of defining our headers and writing this output file, and then it can be easier. It's better. It gets better than that. So let me show you this, and for this I'm going to go over to my solution to dict writer, so that because it's a little bit cruddy to get that. Let me just grab this, and so instead of all this headers stuff, I'm going to use writer. So I'm going to create a CSV dict writer using my args.out file. That's the output file handle where it's going to go, and I need to tell it what the field names are. So I'm still having to do that part, and I also need to tell it what is the delimiter that I'm going to write. And remember, that's going to be taken from the guest delimiter, or you could hard code that to be, a comma. I think the default is a comma anyway. And I do need to tell it to write that header, but now I'm not having to do that manually. So now that I've set up this writer, this CSV dict writer, what it wants is instead what we have here, we were printing all of this values, and we're having to do arg delimiter.join. Well, what we actually want to do is we want to call writer write row instead. Let's format this, and then we can do a side-by-side comparison real quick. Oops, not what I want. Sorry about that, jumping around. So this is what we had before, and I'm going to comment that out for a second. So what we were doing before was we were saying args.out file write, and then we had to specify the delimiter, and then we had to do all of this matter of escaping the data, and we had to remember to add a new line. Well, we don't have to do any of that anymore. That's what the dict writer does for us. So what we pass it is a dictionary that has the same keys as the columns that we told it, and we tell it here we want to print the sequence ID and the percent ID and the depth, latitude, longitude, all of that. It's all taken care of for us. And so if we go back and we make our test again, we see that this version passes as well. But it's, I think, quite a bit easier to remember how to do this. And a lot of that work has been done for us. And if we head on let's run our program again, it's going to export, let's do P90. And so we only have 190. And if we head out.csv, we see here it took care of escaping that for us. We didn't have to remember to do that. So that is another reason why I suggest you use dict writer in addition to dict reader. So now how do we do this with pandas? So first thing I'm going to do is, instead of importing CSV, I'm going to import pandas as PD. We won't be using CSV dict reader anymore. We're going to basically get rid of all of this. Start from scratch. Let me show you how we're going to do this. So I'm going to use the annotations. I'm going to read the annotations using the CSV, read CSV, like we talked about. And I'm going to do the same with the hits, but I'm going to need to give it the name. So it's very annoying, again, that we don't have those for us. So I'm going to go over here and grab this real quick, so I don't have to type all that. And we'll talk about this for a second. So I'm calling read CSV on the annotations file, and I don't even need to say separator is equal to comma because that is the default. And then I'm doing the same thing with args hits. This is still optional, but really names, I have to give the names, and those are the names from output format 6. And if I don't give the names, then it's going to use the first row of data as the names, and it's going to be terrible. And so with that, let's just go through how I'm iterating over this. So I'm calling the iter rows, and I'm showing you a rather painful way to do this because I'm going to be showing you a much easier way in just a second. So let's just print hit and then break, and then we'll just print the first row, and let's just see how our program works. And so we're printing that. We've seen that. That's the same thing that we saw in the REPL, so that's not a surprise. That's how pandas represents one record. So how can we use that? Well, what I'm showing here is maybe we have this way of we're going to create some sort of a data frame manually, essentially, where we're going to create an array of records that we take. So I'm going to call it data. And what I'm going to do is I'm going to go use this very crazy syntax to look in the meta for, I need to find from the annotations, basically I'm looking for this sequence ID. In the annotations it's called sequence ID, and the hit it's called query sequence ID. And so I'm going to see, is it possible for me to get the meta? And I have here this idea, if the meta is not empty, and so we saw that, that if this fails, if it's unable to find in the annotations this sequence ID, then we won't go into this block here. So now for each one of the rows in meta where I find this, because that is going to return itself another dictionary, another data frame, which should only have one, but there's basically, I needed a way of getting at the data inside of meta, so I'm doing another iter rows, which I don't really love. But here, finally, the idea is that I'm trying to get down to the part where I'm going to append this data, and let me format that real quick. So I'm going to append this dictionary that's going to have the query sequence ID, and all that other stuff that we're looking for. Some of this data is coming from the hit, from the hit stuff, and some of this is coming from the sequence object that I'm getting out of this meta. And so that is a way now, and if we go look at this, let's just print data. And you know what? Let's just make it easy. Let's just print. Well, actually, a break here. It'll end up printing a little bit of data. But if we run this, we're going to see, yeah, this big, ugly, it's a list of dictionaries. But if we were to instead print the data, let's just print the length of the data, something a little more manageable. Then we should see 500. And let's see, do we have this? Is this working? Yep, 190. We're now working with the percent identity. This here is doing the selection for the percent identity. So without anything, we get 500. When we specify 90, then we start to get 190. So it seems to be working. And that is pretty good. The last thing that we need to do is we're going to create a new data frame from this, using this from records. This is one way to go about creating the data frame. So this is going to be my output, and then I'm going to call that handy toCSV method that we saw earlier, telling it that I want it to print it to the output file. I do not want that indexed, and the separator is going to be the separator that I guessed from the output file name. And finally, I'm going to print that same information line so that I know what happened. But now I'm going to be using the length of data, and instead of that num taken or whatever I called it before. So if we do that, let's see. Let's just head on out CSV. Let's CSV check. Out.csv looks pretty good. Let's make test to verify that we are passing everything. So this is another way of writing the same thing, but it's still kind of icky and manual. And so there's one last thing that I want to show you with pandas is that you can do something called joining, and which is going back to the very first thing I showed you on the command line, the command line program called join. Well, it's the same idea here. After I've read in the annotations and the hits, I can create this joined data frame by saying, first off, selecting the hits that have a % identity greater than what I'm looking for, joining it on the annotations. In order for this to work, I need to index the files as I'm reading them. So I'm going to have to change the way I'm reading up annotations. Let's go back here. And the way I was doing it before did not have this index column, but now I'm telling it to index on seek ID. And when I open the hits, I need to tell it to index on the column that has the sequence IDs, and here it's going to be query sequence ID. So now that they're both indexed on the same column, I can create a joined, I can join the two on those, and I can create this joined object. And so what happens is that all this goes away. And I can call it joined.toCSV because it is a data frame. And I'm telling it to print to the output file. I'm telling it that it will be indexed. The index column is this query sequence ID, and the columns that I want as the output are the subject sequence ID and that. And I'm telling it what is the output delimiter that I want. And here, what I can do, another way that I could print the output here, the exported, the number of exported and such, is I can use the shape of the joined to show me how many were printed. So let's just run that. Let's see, I have one. Let's see, it's telling me on line 136. Oh, let's see, there we go. Not sure how I changed that. Let's see. Oh, length of data. Sorry about that. And so let's do a make test. Everything passes. It's another way of writing it. But what you have here is this idea of joining two files. And to give you an idea of what this looks like, let's just go back into our REPL. And if I think I've already imported pandas, I'm not sure. Pretty sure I did. Let's read in the annotations file real quick and just take a look at this and get an idea. If we call for annotes.index, we'll see that by default it indexes on the first column. And so what I want to do is instead tell it to index on the sequence column, the sequence ID. And if we look at that index again, now we see something very, very different. If we look at, for instance, the first 10, then we see that. And so now this is the thing that's going to be this index that we can now, it's the sequence ID, and we can use that, for instance, if we do the same thing, to prove to ourselves, we're going to read in the hits, make sure I have my columns defined. Sorry about that. There we go. Columns, and then I will read in my hits file using the names that I have there and telling it that the index column is the query sequence ID. And if we look at what that looks like on the index, we see something very similar to what we saw on the annotes.index, and we looked at the first 10. And so you see here that these values are the same. So now we're going to be able to join on these index columns. And so we can do our wanted, that worked just fine. And we find that we have, if we say wanted.shape, just to verify that we have 190, those are the ones that we've been wanting. Now we want to do this join in between. And so this idea, by default, if you say join, in pandas, it's going to do this, let's see, I think it's going to be an outer join that it wants to do. And what we want to do is this inner join. We only want where the records are present in both of the data sets. So a left join would be everything that's present in the left side, and the ones that are present in the right side, whereas a right join is the other way around, and what we want is an inner join. So when we looked at that joined line, we said how, and that's what the how means, is that we want an inner join, not a left join or a right join. So now we look at joined, I think we can look at join.shape, and we see that there are 190 rows, but now there are 17 columns because it has joined the two together. And if we just look at joined, maybe the first 10, and what that looks like, we see here, now we have all of the data together with the Gauss read ID with some sort of a organism ID here, percent identity. All of these are going to be greater than 90 because of the way we filtered that. And we have, in addition, we have all this metadata, including the latitude, longitude. So that's what's going on with when we're calling joined. Another way to write this is, if you get tired of me saying that, another way to write this is to use this thing called merge. So it is another function inside of pandas. So it is a way of merging the wanted hits that we have with the annotations, and we're telling it that they're indexed, and so this is the syntax I came up with. But if we look at now join.shape, we see again 190 with 17 columns, and if we looked at the first 10 rows, we have the same data. So lots of different ways to do this, but one of the cool things about this is that once we have this as a data frame, we can call this toCSV, and we can tell it specifically, which columns that we want to print, and it will do all that for us. So we have now made it to the end of the book, and now you've learned a lot about delimited text files and some of the tricks that can catch you up, some things to look for, some tools that you can use both in the command line, everything from cut and awk to CSV look, CSV check, and several different ways of going about using Python and Python modules to parse these files. So you could add some other options to your Blastomatic program to select, for instance, for temperature ranges and salinity, blast E values, and all of that. So you could write a really full-featured program to select data for yourself. Some of the things that we talked about, I mentioned shell aliases. Like I showed you how to use a blast check that could, so you could remember those file names, those column names for blast output format 6. I did mention that delimited text files don't always have column headers, and which is the case for that tabular output. And so I've showed you several ways of getting around that, both on the command line with command line tools like CSV check, and also in CSV dict reader and pandas, how to specify what those columns are. We talked about the CSV and pandas modules that can both read and write delimited text files. And really, it's much better for you to use these modules, especially for the writing, because you could forget to do things like, for instance, escape data that has an embedded delimiter. We talked about datasets can be joined on common columns. The join command line tool does that, but we can do this in Python. I used it by using common keys from dictionaries, or in pandas we use these indexes that were common. If those things make sense to you, then joining on SQL, using SQL joins and putting this data into like an SQLite database or PostgreSQL, that might be the next thing that you want to do as you're getting used to working with data. And pandas is a good choice for reading delimited text files if you need all the data in memory, like you're doing some sort of a numerical analysis on all the values in a particular column. So there are good choices for using pandas, but I think that if you are parsing a very large delimited text files, then you're probably better off using the CSV module.